Okay, this is your last reteach section for quadratics, TEK 8, or A8A, which is solving quadratics. So in 16 and 17, we say use the discriminant to find the number of real number solutions. So we don't want the solutions, we want to know how many there are. So the discriminant is the part that's underneath the radical sign in the quadratic formula. So that's b squared. Let's see. Let me write right here. B squared minus 4. Oh my goodness. 4ac. Okay, so the first thing you need to do is find a, b, and c in each equation. So I have it set equal to 0, so check, that's good, it's in standard form. So a is 1, b is -2, and c is 3. So then I just substitute those numbers into the b squared minus 4ac. So that's -2 squared. Again, if you're going to use your calculator to do this, you need to put that -2 in parentheses. Otherwise, the calculator thinks you mean the opposite of 2 squared, and you're going to get the wrong answer. -4 times 1 times 3. Okay, so -2 times -2 is +4. -4 times 1 is -4 times 3 is -12. That gives me -8. My discriminant is less than 1. If it's negative, then there are no real number solutions, since you cannot take the square root of a negative number and get a real answer. So this would be no solution. Or you could say none, but don't say 0. Okay, so no solution. Okay, this one, let's check and make sure it's in standard form. Yes, it is. I have nothing on the other side of the equal sign, but a 0. So a is 1. Don't have an x term. That means b had to be 0. And c is -15. So b squared. So, okay, well, 0 squared minus 4 times a is 1 times c, -15. So that gives me 0. -4 times 1 is -4. -4 times -15 is positive 60. So since my discriminant equals 60 is greater than 1, that means I have 2 solutions. Since the square root of a number is either plus or minus, whatever you multiply together. Okay, solutions. There's an S there. Okay. Now, number 18, 19, 20, 21, 22, you actually need to solve, not just say how many solutions there are. So 18, I have specified by factoring, which means that's going to be factorable. However, this is not in standard form. To solve a quadratic equation, it has to be equal to 0. So we need to bring this 3 over, or subtract 3 from both sides. So this is the trinomial that you are factoring. -3 equals 0. Now, I know a lot of you do the ACB method, but since 2 is prime and 3 is prime, I'm just going to guess and check because I think that's actually easier. So this has to be 2x, and this has to be x. That's the only way I get 2x. I have -3, so one of those factors in the binomial has to be negative, one has to be positive. So if I put my 3 here and my 1 here, that's going to give me 6 and 1. So if I subtract 1 from 6, I get 5. Okay, so, I mean, if you put the 3 with the 2x, it just takes a minute to figure out you did it wrong, and just flip it around the other way. So just let me double check. I have 2x squared plus 6x minus 1x. That gives me 5x minus 3. Now, if both of these are equal to 0, that means at least one of those factors had to be 0. So the only way you get 0 when you multiply things is if one of those things was 0. So you're not done. A lot of people think, oh, I'm done. No, no, no. You have to go and solve these equations. Either the 2x minus 1 factor is equal to 0, in which case 2x would be equal to 1 and x would be equal to 1/2, or x plus 3 equals 0, in which case x would be -3. So your solution here is 1/2 and -3. Okay. Now, there's nothing wrong with graphing that and make sure you got the right answer, but you would need to show the work for factoring to get credit for solving it by factoring. Okay, so number 19 says we have to use quadratic formula. Okay, again, this is not equal to 0, so I first have to fix that. So the trinomial I'm using in its standard form is -20 equals 0. Okay, the quadratic formula, let me write this over here in a different color, is x equals opposite b plus or minus the square root of, I hope I don't run out of room, the discriminant here for AC, and then the whole thing over 2a. So again, the first thing I'm going to do is find a, b, and c. So a is 2, b is -3, c is -20, and put those numbers into my equation here, my formula. And then I know y'all want to use calculators, but this is really a lot easier if you do it by hand, because again, you have that opposite b, you have the b squared and a negative number, and there's a lot of places to make mistakes if you don't type it in exactly right into your calculator. And honestly, doing it by hand is not that big of a deal. So let me maybe a different color, because I'm going to run out of room here. Actually, let me just add another page. Our other page. And now the next three you can do any way you want. You could graph all of them if you want to. Okay, so let's look at number 20. So I'm going to do these probably the easiest way that I do them, and I don't have a graphing calculator here at home. I'd have to go use the one on the iPad here, and that's kind of a pain. So I'm not going to graph them. I'm going to solve them some other way. Personally, I'm really hoping factoring is going to work for these, but we'll see. Okay, so this one, if I look, there's no b term, there's no x term. So that tells me square root will work here, because if I move this 75 over here, now has positive 75, and I can take the square root of that, which will undo this squaring. But before I do that, I'm going to get rid of that coefficient of 3. And when I divide by 3, so that coefficient is 1, I get x squared equals 25, which makes me happy since 25 is a perfect square. Take the square root of both sides, and x is plus or minus 5. Because 5 times 5 is 25, but so is -5 times -5. So you can write, -5, 5, or you could just write it like this as well, plus or minus. Okay, 21. You are planning a rectangular patio with a length that is 7 feet less than 3 times its width. And we know the area is 120, so we need to know what the dimensions are to the nearest tenth. So I am drawing a rectangle, since that's the shape my patio is in. I know the length is dependent on the width, so I'm just going to make that L and that W. And I know that the length is 7 less than 3 times the width. So it's 3 times the width minus 7. And I know that the area is 120 square feet. So to get area, black is better here. To get area of a rectangle, I do length times width, or base times height. That's what you want to call it. So the area I know is 120 square feet. The length is 3W minus 7, and the width is W. So I just distribute my W, and I get 120 equals 3W squared minus 7W. Okay, I'm going to scoot my paper up here and work down here. Here we go. So I'm with, okay, so I'm just going to write it this way. All I did was change which side of the equal sign, so you don't have to change any signs, but to solve this quadratic with the squared, I have to make sure it's equal to 0. So in standard form, this looks like this. Move the 120 over, and so now it's negative. Okay, so I am going to see if I can factor this. And I don't think I'm going to be able to. This has to be 3w, and that has to be w. To get 120, so that when I multiply and combine the middle terms, I'm all the way down to 7. Those are going to need to be big factors, so like 12 and 10. So if I put 12 here and 10 here, I have 36 and 10. No way that's going to give me 7. If I put 12 here and 10 here, I have 30 and 12. There's no combination that's going to give me 7. So before I spend too much more time on it, I'm going to have to use quadratic equation or graphing. But like I said, I don't have my calculator handy. Did not bring it home. So quadratic formula it is. Yay! All right, so opposite b plus or minus the square root of b squared minus 4ac over 2a. See how I'm writing this formula down, like every time I use it? Yep, do that every time I use it. So you should too. Here's the other thing I do every time I use this formula. I write down what a is, what b is, and what c is. That just makes it easier. Just plug the numbers in. A is 3. If I don't write it down and I look up and try to get it, I'm probably going to miss a negative sign somewhere along the lines. And I don't like to be wrong. So, negative 7, and C is negative 120. So, have x equals opposite of negative 7 plus or minus the square root of negative 7. Oops, not 72. Supposed to be a parentheses and a 2 squared. Pretend that's a parenthesis. Okay, minus 4 times 3 times negative 120. Maybe this is why this formula annoys me. I never make that long enough, and it gets all messy on me. So 2 times 3. Okay, let's get some more space. There we go. So x equals opposite of negative 7 is positive 7 plus or minus the square root of negative 7 times negative 7 is 49. Negative 4 times negative 3 is negative 12 times negative 120. Negative 12 times negative 120 is positive 1,440, and 2 times 3 is 6. So x equals 7 plus or minus the square root of, let's see, 1,489 over 6. 1,489 is not a perfect square. So this isn't going to come out perfect, which is probably why the direction of the problem says round to the nearest tenth. So we have x is 7 plus the square root of 1,489 divided by 6, or x is 7 minus the square root of 1,489 divided by 6. It's important when you put this in your calculator too. This whole thing gets divided by 6. So I think if you want to type it in as 1, you need to use parentheses, or you need to do control divide to get that fraction template. In the numerator, you can type 7 plus square root 1489, type 6 in the denominator. What I do, because I forget about the parentheses and that fraction template, I never remember to do that either. I do the 7 plus square root 1489, I push enter, and then I divide by 6, just so I don't And if you don't do it right, you end up only dividing the square root of 1489 by 6, and the answer won't come out right. So you should get x is approximately equal to, I think this one is 7.6. Hang on, I'll go check. Yes, it's 7.59 and, goes on forever. So we're going to round that to 7.6. When you do this one, you're going to end up with a negative answer. And divide that by 6, and that gives you negative 5.26, so about negative 5.3. Now, that is a solution. Let me fix that. That's a solution to this quadratic equation, but it's not a solution for us because, oh my goodness, I can't tell what I'm writing here. Because length can't be negative. I can't have a negative width. So while that is a solution, I kind of throw it away, as my math teacher used to say. I don't need that. It doesn't make sense for our situation. This one does. So since instead of x up here, I'm using a w, this w, where am I going? Oh, why won't that w there? Is that x there? So that means our width is 7.6. So let me see if I can fit everything back up here now. There we go. So if our width is 7.6, that means our length is, I'm going to write it underneath here and then we can erase it if we want, 3 times 7.6 minus 7, which makes this times 3 is 22.8, and 22.8 minus 7 is 15.8. So our length is 15.8. So those are the dimensions, width, length. Okay, so you should have said that if you just wrote down the solution. That's great, but the point is we need to know that you know what that means. Like what is the application of that? So if we just write down the solution, I don't know if you know what that means. Now, I double checked this and I did 7.6 times 15.8 to see if I'd get 120 and get 120.08. So that is as close as you're going to get to an area of 120 feet. So that is your correct answer. That should have come out, if you graphed it, you would have got the 7.6 and the negative 5. So at that point, you needed to say, well, length has to be positive, so I'm going to use the 7.6 and then go figure out the length. I used the formula I wrote for length, but I suppose you could do 120 divided by 7.6. I hadn't thought of that. And you get 15.78, etc. So you'd also get 15.8. You could have done it that way as well. Okay, number 22. A ball is thrown into the air. The height and feet of the ball can be modeled by this equation. The height equals negative 16 t squared plus 20t plus 6, where t is time in seconds with the ball's in the air. When will the ball hit the ground? Well, if I kind of draw a picture, I was hoping I could move that writing. I'm going to scooch over here. If I draw a picture, the ball is thrown into the air. So it kind of looks like this, right? This is your x-axis. This would be your y-axis. So this is a 0. It's where x equals 0 here. It's a solution. It's a 0. It's an x-intercept. It's a root. So that's what you're looking for. You're looking for the x-intercept. Okay, if it asks how high the ball was, that's your vertex, that sort of thing. But this one's our x-intercept. Okay, so we have to solve that and find out when it will cross, that parabola will cross the x-axis. Okay, so I added a new page because I was out of room. So h equals negative 16t squared plus 20t plus 6, and we just figured out to answer the question, we need to solve this equation. And I think we can factor this, which would make me really happy right now. So I see that 16, 20, and 6 all have common factor of 2. I'm going to take a negative 2 out because that'll give me a positive coefficient of t squared, and that's just easier for me to work with. So then this would end up being minus, let's see, 20? No, it is 20. I meant 10t minus 3. Okay, so I'm going to try to factor this. I think I'm going to try 4 and 2. And I need to get negative 3, so one of those has to be negative and 1. So if I do negative 3 here, that'll give me negative 12, plus 1 will give me positive 2, which combined will give me the negative 10. So yay. Now, this whole thing has to equal 0, right, to solve it, because we want the balls on the ground when the height is 0. So negative 2 equals 0 makes no sense, so we don't worry about that one. One of these two factors has to equal 0 in order for the entire thing to equal 0. So we do 4t plus 1 equals 0, and 2t minus 3 equals 0. So over here, I get 4t equals negative 1, so t equals negative 1/4. But we all know time can't be negative. No one has invented the DeLorean time machine yet, for real. So that's a solution to the equation, but not anything. The ball can't hit the ground in negative 1/4 second. That makes no sense. So let's solve this one. 2t equals 3. T equals 3/2, which is 1.5. That makes sense. I could measure 1.5 seconds. So you're not done. You can't just circle these and say, there, I'm done. That's the answer. That might be the solution to the equation, but you did not answer the question. The question was, when will the ball hit the ground? So because I'm on another page, I'm going to write a sentence for that. So the ball hits the ground after, or at, if you want, for 1.5 seconds. Okay, so the very least you needed to write was 1.5 seconds. Okay, I had a lot of people just give me a solution. That's great, but I don't know if you know what that means. Okay, so make sure you answer your questions so you get full credit. Okay, that is the end of your quadratics test reteach. Let's start from here. So here's my formula. Opposite b plus or minus the square root of b squared minus 4ac all over 2a, and that's going to give us our x-intercept, which is our solution, which is our root, which is our 0. Okay, we said that a was 2, b is negative 3, and c is negative 20. Okay, so I'm going to do opposite of b, which is negative 3, plus or minus the square root of negative 3 squared minus 4 times 2 times negative 20. Never make that long enough. All over 2 times 2. Okay, get some more space. So opposite of negative 3 is positive 3. So 3 plus or minus the square root of negative 3 squared is 9. Negative 4 times 2 is negative 8. Negative 8 times negative 20 is positive 160. 2 times 2 is 4. Oops. Okay, so now I combine what's underneath the radical sign. So 3 plus or minus the square root of 169 over 4. And the square root of 169 is 13. So I have two x-intercepts here, 2 zeros, 2 solutions, 2 roots. I have x either equals 3 plus 13 divided by 4, or x could also equal 3 minus 13 divided by 4. So this is 16 divided by 4, which is 4. And this is negative 10 divided by 4, which I'm just going to simplify to negative 5 halves, and I leave it like that. You could say negative 2.5 if you wanted to. You're not wrong. I just don't mind fractions, so I just leave them that way. So our solutions are 4 and negative 5 halves, or negative 2.5 if that's how you did it. And again, you're certainly welcome to graph that and check it on your calculator with a graph, but you need to work it out using quadratic formula for the points. Okay, let's go back